how did the Drought Learning Network start? In 2018, there was an exceptional drought that persisted over the Four Corners area. And during this time, water dried up, crops failed. We saw forest fires start. The 416 fire started near Durango, Colorado. Rangeland conditions deteriorated, and some horses even died from lack of water during this time. We also, however, witnessed we saw those devastating impacts, but we also saw people come together and the extraordinary responses that were possible when people collaborated on finding solutions. And so it was really this devastating drought that inspired the USDA Southwest Climate Hub, the National Integrated Drought Information System, and the National Drought Mitigation Center and other partners to come together to envision a drought learning network. And so when we first came together, we identified why we need a drought learning network in the southwestern United States. And one of those reasons is biophysical. We have increased probabilities of decadal to multi-decadal mega droughts. We're seeing higher temperatures, and those contribute to aridification. And there are increased probabilities of longer and more severe drought moving into the future. So that's the biophysical reason that we need this network. But there are also some more human-related reasons, such as often the communication between climate service providers and resource managers is lacking. Often it's one-directional, unidirectional, so climate service providers will send a lot of information out there, but not necessarily be hearing back from people in the field about, is this information relevant at the time scale and the spatial scale that you're making decisions? Is this what you need? Also, activities can sometimes overwhelm stakeholders during drought if they're not well coordinated. We saw this happen to a pretty great extent during the California drought, 2015 and 2016, where there were so many climate service providers sharing information that it was somewhat overwhelming to stakeholders. The collaboration does help us leverage our expertise and our resources as we work together. It takes the burden off any one institution. And then really importantly, drought impacts go beyond the biophysical impacts to the natural system. They include mental health impacts, physical health impacts. So drought is really a human problem. So what is it? What is the Drought Learning Network? We got together and developed a mission, which is to link climate service providers with resource managers and resource managers with one another to increase landscape and community resilience during current and future drought. The objectives are to document those experiences and needs. What are people asking for and needing to help build some resilience in the system? To leverage service provider resources to better meet those needs, and then to support peer-to-peer learning and collaboration. So this is our current team. This is our current system of the Drought Learning Network. All of the work happens in teams, and we have 5 teams right now. One focused on drought and agriculture, one focused on fire and climate adaptation, and that is our newest team. It was just formed last year. One focused on Indigenous collaboration, and that team has been in existence from the beginning. One focused on sharing management practices, and this team has done some incredible work in working with resource managers and people that are doing things on the ground and documenting this work via case studies that then can be used by other people in other places. So really learning what's working and what's not working in different places related to drought. And then finally, the monitoring and impact reporting group that leads up our drought briefings. So those are the teams. And I want to mention teams can form and dissolve based on need and existing leadership. So if there is something that you would like to see, but you don't see it here and you're motivated to start a team, please let us know. That is an option. And then in the third block of this workshop, these teams will meet and use what we heard during the meeting to build our plans for the next year or two. So we really try to make the best use of our time together. So where are we going? Where are we going with these 3 blocks of time together? At the end of the day tomorrow, we will have those teams that you saw there and maybe some more with 2 to 3 leaders in each team. Each team will also have a communications liaison and several projects or activities that align with what we heard from you during the meeting. Over the next year, all of the work is going to happen in the teams. Again, it's organized by the teams. We do send out monthly emails about activities, new research that's come out, different things that are happening. We will have quarterly all hands meetings. Those are virtual, and we'll be sharing the progress from the teams and also usually some really excellent presentations. The first one I'm thinking about is about a network called Drought, which is a monitoring network. So we're thinking about that for January. And then we hope to have an in-person annual meeting next fall. That's the plan. So these are just a few virtual meeting reminders. Please remain muted if you're not speaking. Also, please feel free to use the chat box throughout the day. Ask questions, share thoughts. You're welcome to use the chat box at any time, and we will try to get to all your questions as we can. If you have any issues or questions during the meeting, and hopefully somebody will drop this in the chat for you right now, feel free to email Tanya, and she can help you with any questions or issues you might run into. And this is my last slide. We know your name because it's there in your chat box, in your Zoom box, but can you please use the chat box to let us know a little bit more about you? We want to know who's here and joining us in the meeting. So your affiliation and where you're located, and one thing you hope to get from this workshop. And while you're doing that and introducing yourself and saying hello to everyone who's here, I will turn it over to Tanya and Brian for the next presentation.
All right. So Brian Fuchs with the National Drought Mitigation Center is going to discuss the making of the U.S. Drought Monitor next here. Go ahead, Brian.
All right. Good morning, everyone. And this has kind of been a little standard since we started the DLN annual meetings, and that was to do just a quick overview on, what exactly how are we looking at and monitoring drought across the country. And Tanya, you can see my slides okay? Okay. So I'm going to just do a really quick, abbreviated 10 minutes. Here's what we do when we're making the drought monitor. The drought monitor is a very important tool, not only for monitoring drought conditions, but it's being used officially in many different programs. And it is really the gold standard for monitoring drought, not only here in the US, but around the world. So I'm going to dig into this real quick and we will show what we got. So what's unique about the drought monitor is instead of focusing on a single indicator or drought index, it's a hybrid approach that we take both the physical indicators and indices along with the knowledge base. And we have about a 500-person email listserv from around the country that we utilize. And they both come together to form the information that's utilized in the U.S. Drought Monitor. Through the beginning in 1999 to present, the Drought Monitor process has been a continuous development process, meaning that as technology and data has changed, as the way we communicate has changed, we've incorporated this into the weekly United States Drought Monitor process. And this comes from the development team, which is a partnership between the National Drought Mitigation Center, USDA, and NOAA. That's where the authors are all housed. And we hear from our stakeholders. We have drought monitor forums every other year where we're learning what our stakeholders want and need and what kind of information we can include in this process. So it's a continuous feedback because we're listening and hearing from our users and stakeholders, but we're also incorporating this into the weekly development of what we do. One of the challenges we do have is we are trying to show all the different types of drought on a single map. And that can be challenging at times because we know, especially in the Southwest and West, how we could have long-term hydrological issues that exist but we still are seeing current conditions doing okay, or a complete different mix of all those. So we are showing on this map meteorological drought, agricultural drought, hydrological drought, ecological drought, as well as socioeconomic drought. And sometimes not all of these are going to be prominent at a single point in time, and that's why we use the labels on the map. So when we do get to the map being presented to the public, we have the U.S. Drought Monitor website at droughtmonitor.unl.edu. This is the official homepage of everything related to the U.S. Drought Monitor. All the data, all the maps, everything associated with this map, the statistics, all come out of this location, as it is the official archive that we have with our partners. Again, we get about 12.5 million hits to this website every year. When drought's more prominent, like we're seeing right now, that's upwards of 18 to 20 million hits in a given year. When we don't have a lot of drought to talk about, then that number can go down. But typically, we're averaging right around 12.5 million. Again, used in several USDA programs. It's being used by the IRS. Several states are using this map to trigger official responses within their state, coordinated with their state drought plan. And others are starting to use this even more and more in official capacities. And I do have the link to the page up in the upper right. So this is what the current drought monitor map looks like. Luckily, I was the author last week, so I know a lot about what was going on here. But this map is trying to show the extent of drought, the intensity of drought, and the relative duration. So what we are using is the labels on the map. So you see the S's and L's and the combination of SL. So that's talking about the duration, where anything 6 months or less is the prominent impacts is what we consider short-term. Longer-term impacts that we're seeing is the L. And it's in many places right now, as you can see on the map, we have a combination of both short and long-term impacts that are going on. How we do this is we look at all the different data and parameters that we have available to us. We don't really produce a lot of the data that we utilize. We're pulling this in from different data providers from around different federal agencies and state and regional partners as well. So what we're seeing on this map is if abnormally dry conditions are on the map, that's saying that the majority of the data that we're looking at is in the 21st to 30th percentile, as we rank all the data from driest to wettest, or lowest reading to highest reading. And then that goes all the way down the line from moderate drought to 11th in the 11th to 20th percentile, severe drought in the 6th to 10th percentile, extreme drought in the 3rd to 5th, or exceptional drought in the 1st to 2nd. And when you get into the D3 and D4 droughts, that's what we're really calling the rare events, because in a 100-year period, you would only expect these types of droughts to happen maybe 3 to 5 times in a 100-year period. So again, the drought intensities are based on this ranking percentile. And what's really useful about this approach is the ranking percentiles methodology can be applied to any parameter regardless of the period of record. And we talked about the frequency, about how often we could see these. And basically, this is the historical likelihood that comes from the disasters literature, showing that the reoccurrence intervals of these. And of course, we know, especially what we've seen in the desert Southwest and why we developed the DLN early on, was some of these intensities were becoming more frequent. And there's many reasons as to why that can be happening, but we definitely were seeing the problem in the region and why the DLN came about. So one of the biggest misnomers of the drought monitor is many people feel that all we're looking at is rainfall. And that's far from the truth. Of course, we know rain and snow are very important in the analysis that we do, but there's a lot more that goes into it. And along with the percentile rankings methodology, we also use what we call the convergence of evidence. And I usually try to relate this to what those on a jury would hear in a trial. All the evidence is laid out in front of them, and the jury has to come to a solution based on that evidence presented. And that's what the drought monitor authors do. We use this convergence of evidence approach where all the information is presented to us, or we're gathering it and looking at it through various sources of information and data. And we're coming to a solution based on what the majority of that data is saying, what's the best solution, how are all the information and data converging into what intensity level. And again, this is related to all the different types of drought, and we're also looking at various timescales. And the timescale issue is complex because we do look at everything that's happened from the last several days to the last several weeks, monthly, seasonal, annual, especially out west. We're even looking at multi-annual or interannual types of data sets because we do know that precipitation is at a premium, and we do know that drought can sometimes really move slower in the Southwest and West than we do in other parts of the country. And all the data that we look at basically is representing some aspect of the water cycle. So from the precipitation coming down to the humidity in the atmosphere to what's being lost through evapotranspiration, vegetation health, the hydrology of stream flow, lakes and reservoirs and groundwater levels, as well as what's in the soil. All the different data we look at capture one of these aspects of the water cycle, and again, utilizing all those different time scales across the top as well. So the majority of the data we look at each week is falling into one of these 6 circles. And so we have our drought indices, we have soil moisture, we have the hydrology of stream flow, reservoirs, wells, and groundwater. We have remotely sensed data, precipitation and snowfall. And then again, that expert local input and impacts, again, the state climatologists, the regional climate centers, the NOAA's National Weather Service offices. We're hearing from all those folks each week. And that's, again, this hybrid process, that's important to incorporate all that. So again, we're looking at dozens of pieces of information at various different time scales. In any given week, there's probably 100 to 150 individual pieces of data being looked at depending on the time of the year and the location. One thing that's changed a lot in the last decade has been the emergence of these satellite products. And again, they are also trying to capture through satellites various aspects of the water cycle. And so we have things like the evaporative stress index, or ESI, quick dry, eddy, gray soil moisture, veg dry, grass cast, even a newer tool that we've developed, and you're going to have the opportunity to hear more about, the forest drought indicator. But all these are really utilizing satellite information along with other land use and climatological data to represent a certain aspect of the water cycle that we maybe don't have tools to do. One thing that's really great about these satellite tools is a high resolution aspect of them, filling in some of the gaps where maybe we don't have surface data. So again, lots of data, lots of information. We're communicating with stakeholders, users, and partners to provide local feedback as well. But that's really my quick a 10-minute overview of the Drought Monitor process. If you'd like to learn more about it, here's my email. I'd be happy to speak with you and answer any questions you have. Thank you.
Thank you, Brian. And Bree, I noticed that you put in some information about data input, so I greatly appreciate that. And again, if you have any questions for Brian later on, or if we have time at the end of the session, we might take a few questions as well. So now we're going to go to Anthony with CTC. Anthony, are you here? Let's see. I'm looking. Hold on. Let me make sure.
Yes, I am here.
Hi.
Taking a little getting used to with Zoom, but
oh shoot, yeah, you guys know
because we use Google Meet a lot.
Yeah, and they're really close, but they're really confusing. I get it. It's like Samsung, Android, and using an iPhone. All right. Well, I'm going to let you go ahead and talk about it. So.
Okay. Let me just share my screen.
Sure. And you can introduce yourself if you'd like to.
Okay.
Mm-hmm.
Let's see. Okay. I hope everyone can see my screen okay now.
Yep.
All right. Excellent. My name is Anthony Artusa, and I work with the Climate Prediction Center, which is located in Camp Springs, Maryland. So what I was going to work on today was to describe La Nina, which is the phase of ENSO that is most favored for this upcoming winter. and associated drought impacts for the Southwest U.S. Now, this map or this schematic that you see here on the front slide shows the typical weather anomalies or departures from normal and the atmospheric circulation during moderate to strong La Niñas. This is kind of giving us a background to work with. This is also for January, February, and March. So we'll abbreviate the seasons. You might see December, January, and February as DJF, for example. But the key here is that for the Southwest, let me just get, pardon me 1 second. I just want to get the laser pointer. For the southwestern part of the lower 48, notice that this region has the storm track mostly to the north and to the east, as well as the positions of the Pacific and polar jet streams. So a lot of the action that's associated with La Nina is both north of your area and east of there. So a few takeaways. One, we are expecting a weak and short duration La Nina. So these composites that we're looking at show 8 of the strongest La Nina composites since 1950. So we have temperature composites here on the left and precipitation composites here on the right. This is for November through March, so we're covering most of the cool season at this point. And thanks to Emily, who mentioned early on, I wasn't sure exactly how to define this box for the Southwest, so I included California and Texas. So I hope that covers it pretty well. But you can see for the temperatures, notice that near to slightly below normal temperatures were showing up on composites on the ones that were listed here throughout the 1950s all the way to 2000. And for the eastern portion of the region, the temperatures have been relatively warm compared to normal. Now, since 2000, we have seen a lot more near to above normal showing up in the composites now for most of the Southwest. For precipitation, primarily a dry pattern compared to normal. And this is pretty clear from Texas right across to Southern California. And then it looks like we have more near normal for the precipitation across northern portions of the area, meaning Nevada, Utah, and Colorado. So on the top left, we have standardized precip anomalies, and these are all composited, and these are the years that are used. And it simply means that we're looking at standard deviation units down here on the bottom. This is for December, January, and February. And notice for precipitation, you typically see drier than normal conditions as we showed earlier, and either near to slightly above across the northern portions of the Southwest. Now, these other charts that you see here, or graphics, these were taken from the WFO, or the Weather Forecast Office in Albuquerque, New Mexico. And these are showing PNP, or percent of normal precipitation for DJF, right? This is mostly for the winter, December, January, and February, using 7 strong La Nina events, and then for 24 mixed intensity La Nina events. So you could have weak, moderate, and strong. And what you see in these two is, for the most part, central and southern New Mexico are the areas that are typically the most driest. That shows up very nicely here in the data. And as we move into the spring, March, April, and May, again, 7 strong and 24, mixed intensity events. You can see that the dryness prevails, especially here from March, April, and May. And then here are the numeric values that go along with that. So trying to build up a background shows that relatively warm and relatively dry conditions are what the Southwest can expect during a La Nina winter. Now, if you notice, I've been mostly talking about moderate to strong La Ninas, right? Because that's where we can get the strongest signal and the best predictability to work with. Unfortunately, we don't have it this time. We have a weak La Nina and a short duration one. So what I did here was using the Physical Sciences Lab compositing tool in Boulder, you can just take 10 years, and I chose the 10-week La Nina years for December, January, and February. So we're looking at pretty much winter. Composite them, what do we get? Well, mostly a question mark, which is that's good and bad. It's good in the sense that when you have a strong La Nina, then you would expect to see more serious drought conditions. But it's difficult or bad in the situation in that the forecast skill is going to be a lot lower. But what this does show is that the best chance for being heavier than normal or anomalously wet is here over Texas. And the best chance, oh, excuse me, that's for dry, pardon me. And then for wetness is here in the blue shading. So this is probably about the most accurate that you're going to get in terms of with weak La Nina years. So 2, relatively warm and dry, as I mentioned, for the Southwest. Here's the November outlook on the top, the temperature and the precipitation. And you can see pretty much above normal for temperature, below normal for precipitation. Then for the seasonal outlook, November, December, January, and pretty much carbon copy. So this is a very stable signal that we tend to see, at least during, moderate to stronger is. Just moving ahead a few seasons, this is for December, January, and February, and then JFM and FMA and so forth. You can see in the Southwest, all relatively warm. The highest odds are in this deeper orange and reddish shading along, say, the Rio Grande and into southern New Mexico and southeast Arizona. For the precipitation, a similar story where we have, in this case, below normal precipitation is favored in the same region throughout the winter months. And also by FMA, it looks like the La Nina will be dropping off or fading rapidly at this point. So the confidence is not quite as high as it was in the earlier season. In terms of current and projected drought, for the current drought, Brian gave an excellent presentation on the drought monitor and how it works. This is the most recent one that he authored that came out last Thursday. And I've just tried to highlight where the highest probabilities for temperature and precip are expected to be in terms of warm and in terms of dry. So this will be the area of the greatest probabilities. That'll be the area we tend to focus on for the more extreme scenarios. For the drought outlook, this takes us through the end of January of 2025, and you can see that 2 shadings prevail over the Southwest, where the drought is currently showing up here in the brown. This is where we expect the drought to persist. And where you see the yellow, it's where we expect drought development, new drought development is deemed likely. So a lot of the Southwest is being covered somewhat with drought currently, but at least some drought looks like it's going to occur during the remainder of the winter. That's just a quick look at soil moisture, which I'm going to skip over for right now. The Pacific Decadal Oscillation, or the PDO. This is a climate phenomenon, yet another one, that can influence the Southwest's drought conditions. And here is its negative phase, where you have near to below normal sea surface temperatures across the tropical Pacific. And we also have this kind of horseshoe shape to the pattern, where these SSTs, or these sea surface temperature anomalies, extend off the West Coast and up into Alaska. The PDO right now is very strong, a minus 3.54. And if you look at this time series, you can see that it looks like it's starting to approach, near record levels. Now, the PDO is often viewed as a longer lived or a lower frequency version of ENSO. It's not exactly, but it's often viewed that way. One last thing I wanted to go into was something called the MEI, or the multivariate ENSO index, which is something that is also looked at in different parts of the country. It has 5 different inputs in version 2. The last one was only for version 1. And the important thing here is notice the current value is minus 0.7. So it's negative, but not really that negative. So here we are looking at the time series again. And here you can see where it is, nowhere near record breaking, but on the negative side. And this is looking at the MEI, the current one in 2024, in historical context relative to these years. And this year seems to be the least negative of all of these. So as you can see, we get a lot of mixed signals. Some indices are stronger, some are weaker, but the bottom line is we expect relatively warm and dry conditions, but not, not record-breaking drought or anything. It looks like this would be a bit of a better year overall, which is more merciful, I think, for the Southwest. And also, I saw there was a reference to aridification, and just a comment here, the PDO, which is a decadal oscillation, being negative would support at least slightly a tendency for more drought at longer time scales. But that's really outside of what we do here at CPC, but I just wanted to share that. So that's what I had. There are some more slides in here, but I just don't have the time to go through them. So please take a look if you're interested. And are there any questions or comments?
Great, thank you for that. We do have time for a few questions if anybody wants to ask questions of Emily, Brian, or Anthony.
I actually have a question for Anthony, and it's about those other indices that you talked about. I've heard people say at different times that sometimes ENSO isn't always the best indicator of drought in the Southwest, or more recently, it's not, that relationship isn't as strong as it may have been in the past. And so I'm wondering, do you give more weight to one of these indices or another? And at which time steps? Like, when would you look at one for one thing and one for a different thing?
An excellent question. Mostly what we look at is, as you noted, there are a lot of different indicators that go into the seasonal and the monthly forecasts. And the biggest one for us is the ENSO. The ENSO is the mode of variability that explains most of the variability, from the tropical areas. So we do have to lean more towards ENSO and composites and also regressions that are based on that. We can use other things, and we do consider other things, such as the PDO, as I noted. We also look at the AMO, or the Atlantic Multi-Decadal Oscillation, and various teleconnections we can use as well, but it's a very tricky business for the Southwest. There's no one signal that can explain everything or is the best in every situation. So to answer your question, I would say that we do tend to focus on ENSO, even though it's far from perfect. And as you noted, it's the correlations that the strong, robust correlations that we used to see in the past are not really working as well now in the future. And we do look at some of the other modes that I just mentioned. These are all considered in the big picture. Okay.
Great. Any additional?
Thank you.
And thank you. Ariel said I had the same question as Emily. So anybody else? Well, if you think of one as we're moving forward, go ahead and type that in the chat box and we can come back to it, or Brian or Emily can answer you in the chat box too, if they'd like, or Anthony. But if we have time, we will definitely try to come back to that. All right. If you want to go ahead and stop sharing.
Yes, give me
I
one
think I'm
second.
double on your screen. Yeah.
Yeah, let's see. There we go.
Awesome. Thank you.
All righty.
I
Thank
had
you.
too many of my faces on the screen. That's scary.
That's
Okay.
good.
So now we want to move on and have a couple updates on some tribal activities that have been taking place. And I'm gonna pass it on to Helena Deswood. She is a tribal liaison for the Southwest Climate Hub. Helena, if you want to give us your updates, that would be great.
Tôi sẽ Helena Desmond siya. Tahas liada ay sinasha tratna sa nation tobaha bashishtin trotsane dashache tratchini dashanella. Hello everyone, I'm the tribal coordinator and I work down in Las Cruces, New Mexico with the Southwest Climate Hub. Back in March, earlier this year, we held the Navajo Nation Climate Adaptation Meeting. It was attended by farmers, ranchers, the college faculty, students, and the surrounding communities, where we learned more about resources and projects from the Navajo Nation Department of Water Resources, Pinon woodlands restorations going on in the area, rangeland health. And we also had presentations from the Navajo Nation Climate Change Program. And we got to hear about the seasonal weather outlook for the Four Corners region as well. Another meeting we held was in July. It was the Navajo Farmer Rancher Congress meeting. This was a first of the meeting after the COVID happened. You know, work has pretty much came to a halt. So we're starting to revamp that Congress, where the main goal is to establish an advocacy and educational organization to identify and give public voice to the resource, policy, and program needs of Navajo farmer and ranchers, and to provide the Navajo farmer and ranchers with education, training, technical assisting, and mentoring needed to establish and grow sustainable and profitable operations, contributing to food security and economic development on Navajo. This was a collaborative meeting with partnership with Dinnett College Land Grant Office and the New Mexico State University Navajo Sustainable Agriculture Project. And new officers were elected, and we are planning another meeting in July. So if you want more information on that, go ahead and contact me. Thanks.
Thank you, Helena. If anybody has questions for Helena, you can also put those in the chat box. And we're going to move on and hear, excuse me, from Tanya Haig at the National Drought Mitigation Center.
Great. Everybody, I have a couple of slides, so I'll share those. I just wanted to give an update on the Drought Smart Indigenous Agriculture Project. Some of you are already very familiar with this project. For others, I'll give just a little bit of background. There we go. The project was funded in, I want to say, late 2022. Our purpose is to enhance agricultural adaptation to drought and climate change for Indigenous farmers and ranchers in the Middle Rio Grande region. This project was funded by a USDA NRCS Conservation Outreach Grant Racial Equity and Justice Conservation Cooperative Agreement. And we've been really grateful for that partnership with the USDA NRCS on this project. I just want to highlight again that this project has had a lot of partners and a lot of people really contributing to the success of the project. So central to the project has been the Santa Ana Pueblo Department of Natural Resources. And I see Tammy Montoya is on the call, which is great. In addition to the NRCS, the New Mexico Department of Ag has been really central. And of course, the Southwest Drought Learning Network itself has been important. Also want to, and as well as the Southwestern Indian Polytechnic Institute, like really all of these partners have been so critical to our work. So over the last year, in general, over this life of the project, now we've done three workshops or co-hosted 3 workshops. They've been Pueblo specific. A lot of them have been out in the field doing things like learning how to do soil testing. We've tried to be very beginner friendly about how do you build resilience to drought. I had a variety of speakers trying to bring resources together and help networking take place. We've always had really good food provided by Colleen, who does some amazing tamales. The Santa Ana Department of Natural Resources followed up on one of our workshops and actually applied for a Healthy Soils grant to do soil testing with farmers at the Pueblo. They did the soil testing over this last winter and got the results back. We put together kind of an educational resource about what does soil testing do? What does it tell you? How does it relate to drought resilience? Talked about that a little bit more at one of the workshops. And we have more to do on that topic. And then I also want to highlight that the project has sponsored 2 interns, and both of those interns have come from, they've been students at SIPI. So we really appreciate our partners at SIPI in helping us, make contact with those potential interns. That's been a great experience. Both of them have been really hands-on, helping with collecting soil for soil tests, helping collect water samples, helping with outreach. You can see a quote from one of the interns there. They have actually both gone on to finish their degrees at New Mexico State University, and so we're hoping that we can keep them in contact through the DLN as well. Next steps, we're still doing some work with those soil tests. We want to create some individualized fact sheets for farmers to better understand what their soil test results mean. The Pueblo is working with the USDA NRCS on the process of applying for a conservation plan so that the Pueblo and farmers will be eligible in the future to secure funding for conservation projects and other efforts to improve their drought resilience. And over the next 6 months, when we'll wrap up this project, we really want to get back in touch with folks and find out, what's been successful, what can we learn from this that might inform future efforts, and really celebrate the last 3 years of working together. It's been a great experience for us. So that is my update.